This conference will now be recorded.
So let them join later. I will going to start the class now. So I'll clear about the derivation what we discussed in last class. That is low frequency control of single area system. In that we have to derive the derivation with two parts. One is static response and dynamic response. In that also in static response there are two cases. One is controlled case, uncontrolled case. Similarly in dynamic response also we have two cases, controlled case, uncontrolled case. So the load already we have discussed. The low frequency control is mainly depends on the two parameters. That is, one is speed changer and one is load demand. So by consideration these two parameters, we can derive these two derivation, that is static response and dynamic response. In the static response, the uncontrolled case, what are the assumptions we have to assume for uncontrolled case?
Delta P is equal to constant, sir. Delta P is equal to variables.
Right. So it means that delta PC equals to 0, and we have to be control the low frequency of a single area system by using delta PD. And we derived the equation. Finally, we got some value, right? The same thing here also we are going to the same derivation, but it is a controlled case. So control case in the sense we are choosing the load demand as a constant, so delta PD becomes 0, and the variable term is delta PC, that is a speed changer value. Okay, now by using speed changer, let me derive that what we'll get. The only difference is there you got finally a delta F divided by delta PD is equals to minus R. Okay, now but here we will get plus R. So that is the difference between these two. So what is the notation means? The minus sign indicates that the controlling action, it is not properly when you are considering that PD as a changing and delta piece as a constant. So that's why its name is called as uncontrolled case. Now we will move to the topic. That is the topic we are going to discuss in this today's class. The low frequency control of single area system for static response in uncontrolled case. So all of you take notes and write down the equation. So these are the derivations we are going to discuss in this topic. So already the first one is over in last class, this one, and now we are going to derive that control case in the static response. Right? All of you note down that block diagram. So this is the block diagram we have for the single area system. Now, in this control case, we are assuming that delta, that is load demand, is a constant. So delta PD is a constant. Then delta PD becomes 0. So here there is no input we are obtaining here. So it is directly cascaded to this block. So then finally we will get that this and this, and so these three blocks are cascaded. So when the three blocks are cascaded, we have to be multiplied. So you will get kg, kt, kp divided by 1 plus stg into 1 plus stt into 1 plus stp. Now after that it should be like a negative feedback loop. Okay. First of all, eliminate this cascaded blocks. Remove this. See, when you remove this one, that is when you are considering the delta PD as a 0, the block diagram is look like this. So here delta PD of s is equals to 0. See, listen carefully. The case what you have to be consider means whether the given case is controlled or uncontrolled. So controlled means it is in our hand, in our generating hand. So we can, based on our requirement, we can generate. Uncontrolled means that is not in our hand, that is completely belongs to the load side. Okay, na? So ఈ రెండు జాగ్రత్త గుర్తుపెట్టుకోండి. So don't be confused there. So after substituting, that is delta PD of s equals to 0, we are getting the block diagram like this. So eliminate the cascaded blocks here. So after eliminating these cascade blocks, we will get the block diagram like this. So this is the block diagram after eliminating that all cascade blocks. Now it is looking like a negative feedback loop. Then from this block diagram, we have to obtain the transfer function, that is delta f of s divided by delta PD of s. Sorry, here it is not PD of s, it is PC of s. Sorry, delta PC of s equals to g of s divided by 1 plus g of s h of s. So here also it will come plus. So find the transfer function from this block diagram. So it is a plus value, plus sign, and it is delta PC, not PD. So after eliminating this, what you will get? kg, kt, kp divided by 1 plus stg. So all terms will get whole divided by 1 plus kg, kt and kp divided by r into all s terms. This will come 1 plus stg, 1 plus stt, 1 plus stp. Now after eliminating this block diagram to the transfer function, we will get the transfer function like this. Just check the transfer function what you got. So this is the term I'm obtaining after this cross multiplication. That is 1 plus stg into 1 plus stt into 1 plus stp. If you bring this, then the denominator both will get cancelled. So finally we'll get kg, kt, kp divided by 1 plus stg the whole term plus kg, kt, kp divided by r. Now what we have to do after this step? What we have to do after this step? What we did in last class after this step?
I think we have to apply final value theorem for that, sir.
Right, right. Now apply the final value theorem. What is the final value theorem? Limit s tends to 0, s into delta of s. So that is delta f stat is equals to limit s tends to 0, s into delta f of s. Okay. So here there is one more assumption we have to change. We have to be considered. That is a step change in the input. That is a speed changer. What you will get here? If there is a step change in the input, what you will get? Delta PC divided by yes. Okay. Now, so this is a step change in the speed changer. See, for a step load change, the delta PC of s equals to delta PC by s. If you substitute instead of delta PC of s, delta PC by s. After this, we have to apply the final value theorem that was given by delta f stat, that is static response of low frequency control equals to limit s tends to 0 s into delta f of s. So if you substitute this equation in this, what you will get finally? After substituting in the Laplace transform, what you will get? So here s get cancelled and substitute s term s is equals to 0 here. Then finally you will get kg kt kp divided by 1 plus kg kt kp divided by r into delta pc. So this is the equation we will get here. So after this step, apply the Laplace transform and substitute there, and then we will get that this equation kg kt kp divided by 1 plus. Let me see. Let me check your answer here. So this is what we obtained after substituting in Laplace final value theorem. Now here practically the kg kt value is equals to 1. Now if you substitute 1 here, we will get kp divided by 1 plus kp by r into delta pc. Now from this equation already we have the kp value is equals to 1 by b, already we derived in the previous derivation. If you substitute kp is equals to 1 by b, what you will get here? What is the equation you are getting here? So if you substitute kp divided by 1 by b, delta f stat is equals to 1 by b divided by 1 plus 1 divided by br into delta pc. How we can simplify this? Take take the 1 by b from the denominator. So if you take common 1 by b, so 1 by b divided by, take the 1 by b as a common here, you will get b plus 1 by r. So both will get cancelled. You will get finally 1 divided by b plus 1 by r. So just substitute the kp is equal to 1 by b in this equation. Now after substituting that Kp is equals to 1 by B, you will get the equation like this. 1 divided by B plus 1 by R. So in this case, already here the B value is a load damping constant. So already we said the changing in the load is 2%. It will make that 1% change in the frequency. Yeah. And delta PC is a incremental change in speed changer, and that stat is equals to 1 divided by B plus 1 by R here into delta PC. Now after now we have to be related between the what is the value of B with respect to 1 by R. See here the system performance in terms of how the change in the power affects the change in the frequency. So that was given by area frequency response coefficient. So in this case B is less than the 1 by R. So we have to eliminate the B value, then we will get that R. So 1 divided by B plus 1 by R is there, right? So when B eliminated, you will get 1 divided by 1 by R. So B will comes to the numerator, then finally we will get that R value here. So this is the equation of transfer function that is in uncontrolled case. Delta F stat divided by delta PC is equals to R. In previous derivation, we got minus here. So the sign indicates that whether it is action is controllable or uncontrollable. So that is the notation is given by sign, negative sign and positive sign. And so after see what is the main intention of this low frequency control means this type of analysis should be done in the transmission line system. So transmission lines done by them considering that transmission line system. Why? Because there is a huge amount of losses will be occurring in the transmission line system, like voltage drops. I mean, different losses we have, right? Corona loss and Ferranti effect, skin effect, proximity effect. So due to the different types of effects, we are getting the losses. Now our aim is based on the voltage levels in the transmission line system, and we have to be make it as a this type of block diagram. So we have a block diagram, right? In that block diagram, we have to be design that parameters based on the voltage level in the transmission line capacity. Okay, na? So this is about control case in the steady state response, and here we are going to discuss about transmission line voltage levels. Okay, na? So that is the general topic, but just recalling for you. Okay, na? So already మీరు EPTs చదివింటారు, just మీకు recall చేయడానికి చెప్తున్నాను. So why? Because while designing this type of steady state analysis, they have to be considered that transmission line voltage levels. So before that, we have to know that what is the voltage levels in the transmission system and where we can use this type of static state response, that we have to be know, right? So this is the steady state response for use. So here you are not getting the, so this is the positive sign here. So this is the equation for multiple generators we are connected with performing the speed governing regulations. So now we will discuss that what is the voltage levels in the transmission line system. So can you tell me that what are the different type of voltage levels having in the transmission system? Ratings of voltage level. what are the voltage levels that our transmission system having? I mean ratings. So I need totally. So మన transmission lines లో 3 categories ఉన్నాయి: short transmission line, medium and long transmission line. So in the three, what are the voltage levels? So we have the first one is 11 kV, 33 kV, 66 kV. Next, you move now. 110 kV, 132 kV, 6th one is 220 kV, and 7th one is 400 kV. So these are the different voltage levels carried by the transmission system. Okay now, so this voltage, these 7 voltage levels carried by the transmission system. In that, transmission system is classified into 3 types, that is short, medium and long transmission line. Out of these 7, what is the rating of voltage carried by the short transmission line? What is the voltage level carried by the short transmission line out of these 7? షార్ట్ ట్రాన్స్మిషన్ లైన్ లో వోల్టేజ్ లెవెల్ ఎంత ఉంటుంది? వాట్ అబౌట్ అదర్స్? వాట్ ఈస్ ద వాల్యూ ఆఫ్ వోల్టేజ్ లెవెల్ ఇన్ షార్ట్ ట్రాన్స్మిషన్ లైన్? So in short transmission line, the voltage level having only 11 kV. Why? Because enduku? What is the rating? What is the voltage level rating? That is a maximum voltage level rating in the short transmission line. So I'm asking, what is the voltage level in the short transmission line? That is 11 kV. What is the maximum allowable voltage level in the short transmission line? What is the voltage level capacity in short transmission line? Maximum value. No. See, the short transmission line, the voltage level is less than 20 kV, and its distance is 50 kilometer. Okay, that's why the short transmission line having the capacity to carry that only 11 kV. Next, what is the rating of voltage levels for the medium transmission lines? Medium transmission lines ఎంత voltage levels ఉంటాయి? What are the voltage levels in the medium transmission line? So the medium transmission line capacity is 33 and 66. Why? Because its voltage level between 20 kV to 100 kV. This is the voltage level rating in the medium transmission lines. And remaining 4, we have the voltage levels in the long transmission line. Okay. So these 7 voltage levels, we are having that transmission line capacities. Okay, now we will show you video, then you will get clarity on that. in which transmission line, on what is the voltage capacity and what is the distance. Just see the video, then only you will get the clarity on this. Mahesh, there is no 69 kV. We have only 11, 33, 66, 110, 132, 220 and 400. There is no 133 also. So we have only 132 kV. So actually, this is the video in Hindi language. Just understand that. Understand the concept. See, operation voltage level is less than the rated value. ఎందుకంటే when there is a load connected transmission line, there is a drop in the voltage level. సంగా voltage level తక్కువ ఉంటుంది. Wait, it's not opening here.
इसी के अंदर आ गया। और इसका जो लेंथ के बारे में बात करेंगे वो कितना हो जाएगा हमारा 0 से 80 किलोमीटर हो जाएगा। तो उम्मीद है दोस्तों आपको शॉर्ट ट्रांसमिशन लाइन समझ में आ गया होगा। उसी प्रकार हम लोग अब मीडियम ट्रांसमिशन लाइन के बारे में देखने वाले हैं। जो मीडियम ट्रांसमिशन लाइन होता है उसका अगर लेंथ के बारे में बात करने वाले हैं तो लेंथ जो इसका होगा 80 से 200 किलोमीटर की जो लाइन होगी वो आपकी मीडियम ट्रांसमिशन लाइन के अंतर्गत आ जाएगी। तो लेंथ के हिसाब से हम लोग आज देख लिए। अब बात करेंगे हम लोग अगर ऑपरेटिंग वोल्टेज का, कि जो मीडियम ट्रांसमिशन लाइन जो होती है उसका जो ऑपरेटिंग वोल्टेज होता है दोस्तों वो 20 केवी से 100 केवी तक की लाइन को क्या बोलते हैं, ऑपरेटिंग वोल्टेज को मीडियम ट्रांसमिशन लाइन बोलते हैं। तो मीडियम ट्रांसमिशन लाइन हो गया। अब हम लोग जो इसका एग्जांपल देखेंगे, बेस्ट एग्जांपल, तो आपका जो है 20 केवी से 100 केवी के बीच में कौन सा आ गया, 33 केवी और 66 केवी जो है बेस्ट एग्जांपल हो गया। तो आप देख सकते हैं ये किसके अंतर्गत आ गया, आपका मीडियम ट्रांसमिशन लाइन के अंतर्गत आ गया। उसी प्रकार हम लोग अब लॉन्ग ट्रांसमिशन लाइन के बारे में देखने वाले हैं कि लॉन्ग ट्रांसमिशन लाइन होता है उसका जो लेंथ होगा वो कितना होगा। तो अगर हमारा लॉन्ग ट्रांसमिशन लाइन है तो उसका अगर लेंथ के बारे में बात करें तो आपका जो लेंथ आएगा वो 200 किलोमीटर से ऊपर आएगा। मतलब जितने भी 200 किलोमीटर की लेंथ से ऊपर होगा वो आपका लॉन्ग ट्रांसमिशन लाइन के अंतर्गत आ जाएगा। उसी प्रकार हम लोग लॉन्ग ट्रांसमिशन लाइन का अगर हम लोग ऑपरेटिंग वोल्टेज का बात करें तो जितने भी आपके जो 100 केवी के ऊपर की लाइन होगी उसे क्या बोलेंगे, लॉन्ग ट्रांसमिशन लाइन बोलेंगे। अगर इसका बेस्ट एग्जांपल होगा तो आपका कितना हो जाएगा, 110 केवी, 132 केवी और 220 केवी और लास्ट में आपका जैसे 400 केवी, ये सब किसके अंतर्गत आ जाएगा, लॉन्ग ट्रांसमिशन लाइन के अंतर्गत आ जाएगा। अगर दोस्तों मेरा वीडियो अच्छा लगा हो दिल से लाइक करें और
Right. So I will ask one more thing. How we can identify that transmission line whether it is having the particular voltage level? Okay na? So మీ ట్రాన్స్మిషన్ లైన్ చూస్తానే సో ఈ ట్రాన్స్మిషన్ లైన్ వోల్టేజ్ లెవెల్ ఇంత ఉంది అని ఎలా ఐడెంటిఫై చేస్తారు? How we can identify that kV value in the transmission line? Can anybody say that? How we can identify the kV value in the transmission line? While looking the transmission line itself, you can identify that what is the voltage level carried by the transmission line. How we can find, how we can determine that? Based on insulator. Super. So based on means at what way? So insulator base చేసుకొని కరెక్ట్, బట్ ఎలా అని అంటే టైప్ ఆఫ్ మెటీరియల్ లేదా టైప్ ఆఫ్ షేప్, at what consideration of insulator we can use different voltage levels. Right, super. So based on the number of discs we can say that the voltage level is carried by the particular line. Suppose if you see that 11 kV transmission line, suppose we have the 3-phase 11 kV transmission line, we have the 3 poles here and each carried by R phase, Y phase and B phase. Here the insulator we are using the disc type, right? So disc type we have the poles like this. So we have 2 poles and based on the 2 poles we have the 3 phases R, Y, B and these are connected through the insulator which is having that 1 or 2. So for 11 kV we can identify while seeing the insulator. So it requires 1 or 2 disc type insulator. Okay now. Similarly we can say that the voltage levels based on the number of insulators. Okay. So based on this I will show you one video, then you will get clarity on this at what voltage level the number of insulators we can use. So this is the most important concept. Okay now. So why? Because the strength, the insulator strength is given, the number of insulators is required for the capacity of the transmission line. So it means that if it is short transmission line means it carries only 11 kV. So 11 kV means it is using for the only short line distance. So short line distance means we can the mechanical strength requires less. Okay now. So ఆ విధంగా మనకు డిఫరెంట్ kV values కి ఎలా ఐడెంటిఫై చేస్తామంటే based on the number of insulated disc. So ఇప్పుడు మీకు 11 kV కు 11 kV ఐడెంటిఫై అంటే and it has that 1 or 2 discs. ఓకేనా? సో మీకు ఇంకొక వీడియో చూపిస్తాను. దెన్ ఇట్ షోస్ దట్ how we can identify the kV value based on the number of insulated discs. Students, this is the most important concept. So you may get competitive exams also based on this concept. That is voltage levels in different types of transmission lines on this one.
आज की इस वीडियो में हम लोग देखने वाले हैं कि हम लोग कैसे पहचानेंगे कितनी केवी की लाइन जा रही है। जो हमारी ट्रांसमिशन लाइन जो होती है वो 11 केवी, 33 केवी, 66, 132, 220, 400, 765 केवी की लाइन होती है। तो हम लोग आज इस वीडियो में हम लोग आज आसानी से पहचान पाएंगे कि कितनी केवी की लाइन जा रही है। फोटो दिख रहा है, ये क्या है? 11 केवी की लाइन है। मैंने कैसे पकड़ा है कि ये 11 केवी की लाइन है? फर्स्ट ऑफ ऑल, ये क्या आपका दो पोल दिख रहा है, तो इसे बोलते हैं डीपी, डबल पोल या ड्यूल पोल। तो जब आप 11 केवी डीपी के पास जाओगे ना, तो आपको हर सिंगल फेज पे क्या मिलेंगे? एक एक डिस्क इंसुलेटर मिलेंगे। ये जो इंसुलेटर दिख रहा है इसे क्या बोलते हैं? डिस्क इंसुलेटर। तो आप देख सकते हैं आर वाई बी तीनों फेज पे क्या है? आपकी एक एक डिस्क इंसुलेटर लगे हैं। इसका मतलब ये हुआ कि ये 11 केवी की लाइन है हमारी। जो आपको डिस्क इंसुलेटर मिलेंगे वो कहां पर मिलेंगे? या तो आपको डीपी पे मिलेंगे या तो आपको टैपिंग चैनल पे मिलेंगे। तो वहां पर दो लोकेशन पे आप जाके आसानी से पहचान सकते हो। फिर आप अगर वी क्रॉस के पास जाओगे ना, तो वहां पर जो पिन इंसुलेटर मिलेंगे वो आपको थोड़ा छोटा मिलेगा। तो इससे भी आप समझ सकते हो। अब जो हम लोग देखने वाले हैं कि हम लोग 33 केवी लाइन को हम लोग कैसे पहचान पाएंगे। ये जो लाइन दिख रही है ये हमारी क्या 33 केवी की लाइन है। हम लोगों ने कैसे पहचाना कि हमारी 33 केवी की लाइन है? तो सिंपली जो 33 केवी की लाइन जो होगी वो आपके तीनों फेज में जो होगा, मतलब पर फेज जो होंगे वो आपके तीन तीन इंसुलेटर लगे होंगे। सपोज आर में आपको कितने होंगे? 3 डिस्क होंगे। उसी तरीके से वाई बी में भी 3 डिस्क इंसुलेटर होंगे। इससे हम लोग आसानी से पहचान पा रहे हैं कि हम लोग ये क्या है, हमारे 33 केवी की लाइन है हमारी। और अगर वी क्रॉस और इंसुलेटर से देखना है तो हम अगर गौर से देखेंगे तो 11 केवी से जो होगी वो थोड़ी बड़ी होगी वी क्रॉस, और आपके पिन इंसुलेटर भी होंगे 33 केवी की क्या होगी? 11 केवी से बड़ी होगी। इससे भी हम लोग पहचान सकते हैं। जो आपकी ट्रांसमिशन टावर्स जो आप लोगों ने देखा होगा ना, वो आपको 66 केवी से जो है स्टार्ट होता है। टावर्स का यूज कब करते हैं हम लोग? मिनिमम जो होता है 66 केवी से क्या होता है, हमारी टावर्स लगना स्टार्ट हो जाता है। उसके ऊपर जितनी भी लाइन होगी ना वो
So generally the 11 kV and 33 kV should be carried by the pole mounted. But when we go for more than 33 kV, we require that towers. So it means they're capable, the mechanical strength of conductors to carry this amount of 66 kV, it requires more mechanical support. So that's why the voltage more than 33 kV, we go for towers to carry the conductors.
सारे टावर्स के थ्रू आएगी। तो इसमें हम लोग सबसे पहले दो इंसुलेटर देख लेते हैं, क्योंकि मोस्टली आपको यही दो इंसुलेटर देखने को मिलेगा। इसके बाद हम लोग आसानी से 66 और उसके ऊपर वाले वोल्टेज वाली लाइन को हम लोग आसानी से पहचान पाएंगे। जो है आपका सस्पेंशन टाइप इंसुलेटर, ये क्या होता है? वर्टिकल में होता है। जैसे कि आपको फिगर में दिख रहा है, ये जो नंबर ऑफ इंसुलेटर रखे हैं वो कैसा है? वर्टिकली रखा हुआ है। तो इस टाइप को क्या बोलते हैं? सस्पेंशन टाइप इंसुलेटर। और एक और होता है आपका स्ट्रेन टाइप इंसुलेटर। इसमें क्या होगा? जो नंबर ऑफ इंसुलेटर जो रखे होंगे ना, वो आपके हॉरिजॉन्टली रखे होंगे। तो उम्मीद है आपको ये दो टाइप के इंसुलेटर समझ में आ गए होंगे, और यही चीजें आपको टावर्स में दिखने को मिलेगा। जो लाइन है आपकी 66 केवी की लाइन है। मैंने इसे कैसे पकड़ा हूं, तो आपको मैं बता दूं। ये जो आपको डिस्क, जो आपको नंबर ऑफ डिस्क इंसुलेटर यहाँ पर क्या हुई वर्टिकल फॉर्म में है, तो ये सस्पेंशन टाइप ऑफ इंसुलेटर आपके यहाँ पर लगी हुई है। आपको सिंपली क्या करना है? नंबर ऑफ डिस्क को काउंट करना है। तो आप जैसे ही काउंट करोगे ना, तो आपको 5 नंबर ऑफ डिस्क मिलेंगे। मतलब ये 66 केवी की लाइन है। तो 66 केवी की लाइन में कितने होते हैं? नंबर ऑफ डिस्क इंसुलेटर जो होते हैं वो 5 होते हैं। मतलब जो है हमारा पर फेज कितना इंसुलेटर आपको देखने को मिलेगा, 5 डिस्क इंसुलेटर देखने को मिलेगा। तो इससे हम लोग आसानी से पकड़ पाते हैं कि कितने केवी की लाइन जा रही है। तो ये हमारी कैसी है, 66 केवी लाइन है। आपको रेयर केस में कभी कभी जो आपको 6 डिस्क इंसुलेटर भी दिख सकता है। तो ये आपको कब दिखेगा, जब स्टैंड टाइप ऑफ इंसुलेटर लगे होंगे ना, मतलब हॉरिजॉन्टली लगे होंगे, तब जाके आपको 6 इंसुलेटर देखने को मिलेगा। तो वो भी क्या होगी, हमारी 66 केवी की लाइन होगी। ये जो टावर है ये कितने केवी की है, जो लाइन जा रही है ना हमारी, वो हमारी 132 केवी की लाइन जा रही है। मैंने कैसे पकड़ा, सिंपली फिर आपको वही ट्रिक।
So after 66 kV, it is more than 100. We are going to use the double circuit, three-phase double circuit. So what is the advantage of three-phase double circuit? So why we are using the double circuit here? What is the reason? Why we are using three-phase double circuit when the voltage level is more than 100? What is the purpose?
దాన్ని యూజ్ చేసుకొని మెయింటెనెన్స్ కాస్ట్ రిడ్యూస్ చేసుకోవచ్చు సార్. అంటే ఒక్కటే ట్రాన్స్మిషన్ వరకు, అంటే ఇప్పుడు ట్రాన్స్మిషన్ టవర్ ఆ పక్క ఈ పక్క వేసుకుంటూ వెళ్ళిపోవచ్చు సార్. అంటే మెయింటెనెన్స్ కాస్ట్ రిడ్యూస్ చేసినట్టే కదా.
Right. So why we are using the double circuit means at the event of fault and repair, there is no need, there is no occurrence of interruption. ఓకేనా, డబుల్ సర్క్యూట్ ఎందుకు యూస్ అంటే ఎప్పుడైనా ఫాల్ట్ అక్కర్ అయినా కానీ రిపేర్ చేయాల్సి వచ్చినా కానీ ఇంటరప్షన్ జరగకుండా ఒక సర్క్యూట్ నుంచి మనం కంటిన్యూస్ చేసుకుంటూ ఉండొచ్చు. ఓకేనా, దట్ ఈస్ ద థింగ్ వీఆర్ యూజింగ్ ద డబుల్ సర్క్యూట్. అండ్ వన్ మోర్ థింగ్, టు రిడ్యూస్ ద కరోనా ఎఫెక్ట్ ఆల్సో. ఎందుకంటే ఎప్పుడైతే కండక్టర్ సైజ్ పెరుగుతుందో దెన్ వీ కెన్ రిడ్యూస్ ద కరోనా ఎఫెక్ట్. Okay, right. So let me see that for 132 kV, how we can identify that number of discs. So for 132 kV, let me see how many discs we can require.
नंबर ऑफ डिस्क इंसुलेटर काउंट करना है। तो यहाँ पर आपको देखना है जो डिस्क इंसुलेटर है वो किस फॉर्म में, वर्टिकली है, मतलब सस्पेंशन है, ठीक है। तो इसमें नंबर ऑफ डिस्क जो होंगे ना वो 9 होंगे। तो सबसे ज्यादा जो आपको ना सस्पेंशन मतलब वर्टिकल फॉर्म में ज्यादा मिलेंगे आपको
1
टावर्स
2
में, जो
3
ट्रांसमिशन
4
हो जाएगी।
5
तो
6 7 8 9, so 9 discs required
देख सकते हैं
for 132 kV.
इसमें आप काउंट कीजिए, देखिए कितना है आपका 9 डिस्क इंसुलेटर है। तो ये आपकी कितनी केवी की लाइन है, 132 केवी की लाइन है। अब आपको अगर आपको 10 भी दिखेगा, ठीक है ना, ऐसा नहीं है कि 9 ही दिखेगा, 10 भी दिखेगा। जब आपको हॉरिजॉन्टली जब स्ट्रिंग क्या होगा ना, नंबर ऑफ डिस्क लगे होंगे ना, तो वहां पर आपको 10 देखने को मिलेगा। देख सकते हैं जैसा कि फिगर में आपको देख सकते हैं, काउंट कीजिएगा आपको तो आपको 10 देखने को मिलेगा। मतलब ये भी आपकी जो है 132 केवी की लाइन जा रही है। तो 132 केवी में 9 डिस्क इंसुलेटर भी हो सकते हैं और 10 भी हो सकते हैं। तो 9 10 मिले मतलब 132 केवी की जो हमारी लाइन जा रही है। बहुत लोग सोच रहे होंगे कि टावर के स्ट्रक्चर को भी देख के हम लोग बता सकते हैं कितने केवी की लाइन जा रही है। बिल्कुल बता सकते हैं, बट इसमें ज्यादा कंफ्यूजन होगा। जो उस लाइन में काम कर रहे हैं ना वही सिर्फ बता सकते हैं, बाकी और अननोन पर्सन ना बताना थोड़ा मुश्किल होता है। इसलिए आप इजी भी होगा कि नंबर ऑफ डिस्क इंसुलेटर को देखते हुए आप केवी को डिसाइड कीजिए।
సో ఇక్కడ 9 10 ఇచ్చారు కదా. సో 9 10 అనేది ఎక్కడ ఇస్తారంటే if it is suspension type we are using the 9 discs. If it is straight, that is it is straight to the connectors, we are using the 10 discs. Okay, now that is the difference. So for 132 kV we can use 9 discs as well as 10. So based on the how insulator are suspended, if it is suspended vertically then we can use the 9 insulators, horizontally we can use 10 insulators disc.
प्रकार आपको 220 केवी में 15 से 16 डिस्क इंसुलेटर देखने को मिलेंगे। उसी प्रकार 400 केवी में 30 से 31 डिस्क इंसुलेटर देखने को मिलेंगे और 765 केवी में आपको जो है।
So for 76 kV we have to be use 57 to 58, you know.
इसी प्रकार आपको 220 केवी में 15 से
for 220 kV it requires 15 to 16. Just note down that this will be useful for your future.
16 डिस्क इंसुलेटर देखने को मिलेंगे। उसी प्रकार 400 केवी में 30 से 21 डिस्क इंसुलेटर देखने को मिलेंगे और 765 kV में आपको जो है 57 to 58 डिस्क इंसुलेटर देखने को मिलेंगे। तो इस तरीके से आप आसानी से नंबर ऑफ डिस्क इंसुलेटर काउंट कर आसानी से पहचान सकते हैं। अगर मेरा वीडियो आपको अच्छा लगा हो
so based on this type of voltage levels, we can manufacture and we can design that how the response will be maintained. So actually, so if it is so this is the called as single area system, right? So here let me see this block diagram. So if there is any changes should be occur. So ఇక్కడ changes అనేవి దేనిపైన డిపెండ్ అంటే the losses which was occurring in the transmission system. So ఇక్కడ parameters అనేవి దేనిపైన డిపెండ్ అంటే whether the system, that is the single area system, is coupled to the long transmission line, short or medium. So based on that they will having that parameters with respect to the generating power level. Okay na? So ఎందుకంటే మనకు voltage level different ఉంది. Based on that voltage levels we have to be consider different parameters. So okay students, this is about today's class. So the two topics is over in the static response. So in tomorrow class we are going to discuss about dynamic state response for uncontrolled case and controlled case. Okay na? So this is about today's class. And one more thing, let me know that how many of them going to apply the gate exam from your class? How many of them going to apply the gate exam? So let me know how many of them. Okay, I will so తర్వాత ఇన్ఫార్మ్ చేస్తానండి. సో టైం అయిపోయింది. సో ఈ రోజు క్లాస్ ఎండ్ చేస్తున్నాను. ఓకేనా? సో టుమారో క్లాస్ we are going to discuss about dynamic state response. Thank you.